All right, here's a little bit of the agenda for today. So we're going to talk about migration strategies, a project that we wrote for this purpose, so we will discuss that, how the migrations work, the concept of replicas, a demo, of course, and some more information about validation and testing, okay? So let's put a little bit of context to begin with, you know? So why are we talking about migrating workloads to begin with? How many of you guys here have VMware in your infrastructure? Okay. How many has OpenStack? Okay, good. Docker? Okay, a few, perfect, thank you. So the main idea is this one, you know, companies are typically moving across different generations of computing software, right? For example, a few years ago, let's say 10 years ago, everybody moved from physical servers to virtualization, right? And that was actually a big move. Actually, nowadays, it's very difficult to find companies which still run their infrastructure on physical servers. Almost everybody runs it virtualized. And 10 years ago, you know, hypervisors were all the rage. Should I use Hyper-V? Should I use VMware? Should I use, well, the upcoming KVM or Xen and everything, you know? And every hypervisor had different features, and people were choosing a hypervisor based on the type of features. Nowadays, hypervisors are more or less commoditized, so you can expect from every hypervisor on the market, KVM, Hyper-V, ESXi, and everything, to perform all the basics operation that you will expect in a virtual infrastructure. No? Of course, there are still differences. For example, for an enterprise deployment, ESXi or Hyper-V are still way better than KVM, okay? While for a large scale deployments, companies tend to prefer KVM, okay? Because of its open source nature and so on. That's not the topic, of course, of the session here today. There will be quite a lot to talk about this, but we won't, okay? The next level, and that's actually where we are mostly interested for this session, is actually the move from traditional virtualization to infrastructure as a service. What's the difference between just running a bunch of virtual machines on, let's say, VMware or Hyper-V or whatever, and running a full infrastructure as a service, like, for example, OpenStack? The big difference is that everything becomes automated. So everything has REST APIs on top so that you can automate storage, you can automate networking, software-defined networking now. You can automate compute, so it's way more than just go create a virtual machine and pass the credentials to users. It's all about allowing your users to do that by themselves, you know, by providing, of course, a self-service portal or a bunch of API endpoints and whatever else, okay? Then, of course, you have public clouds like Azure or AWS or GCE or Oracle, and you have on-premise cloud, where, of course, OpenStack is the king of the scene. No? So a few years ago, everybody was interested in doing that. Nowadays, we consider typically the infrastructure as a service as pretty much consolidated, right? So the public clouds, you know who the winners are, you know, Amazon, Azure, and newcomers like GCE or Oracle, you know, getting a big dent as well in the market. And on the private cloud, well, OpenStack is the de facto open source cloud technology, right? The next wave, it's all about what you're running on top of infrastructure as a service. For example, OpenStack got some critics about the fact that it shouldn't necessarily get involved in things which are outside of the infrastructure as a service itself, no? Shuttleworth famously called it bullshit as a service, okay? Pardon the French here. But somehow it's true, a little bit. OpenStack went beyond, let's say, the basic infrastructure as a service work, so meaning storage, networking, compute, and everything, and started adding a ton of things on top of it. Those things got received with a little bit of mixed success for the simple reason that they are outside of a plain simple infrastructure as a service world. That's where actually containers are. And moving forward, that's actually where the serverless world is, okay? Serverless is the latest marketing terminology that everybody's using to talk about things that in the end are running on top of servers. So they're serverless from the point of view of the users, of the developer. The developer uses technologies like I don't know, Azure Functions and everything to create their applications without thinking about where those applications are running. But underneath, there will still always be an infrastructure as a service. So if somebody tells you OpenStack is dead, that's crap. That's really not true. OpenStack is alive and well. It's the simple fact that people are thinking typically about the next wave. So Kubernetes, for example, will have to sit on top of an infrastructure as a service layer. Doesn't matter if it's GCE, AWS, Azure, or OpenStack, okay? So how do we help companies going across all those paths? So how do we help them moving from physical to VMs to infrastructure as a service and so on, okay? So that's actually the topic of the session today. In particular, we will focus around these two around here, which are where most of the companies are stuck nowadays. Why, to begin with, should we migrate those workloads? Why aren't workloads just happy the way they are? People want to migrate their workloads because they want to take advantage of the latest technologies to begin with, and most important, they want also to spare money. Examples are you might not have a new on-premise cloud infrastructure, brand new shiny hardware. Well, you want to migrate your stuff from the old hardware to the new one, and since you're at that, you might also want to get to the next generation of technology. Yay, talking about technology, we might actually be able to see something with the demo. Okay, perfect. Okay, thank you. Okay, that was our first demo. It worked. We migrated from not seeing anything to seeing something. Perfect. So other types of reasons why you might to migrate, it's on-prem to public cloud. Now, of course, every company involved in public cloud is investing a ton of money in marketing, trying to get you on top of a public cloud, right? That's what, of course, Microsoft is doing all the time right now. Well, Amazon is a company, I mean, for the public cloud part that doesn't even have an on-prem counterpart, so of course that's what we are trying to sell you. Same thing for Google, same thing for Oracle and everything, okay? And obviously moving to a public cloud is a good idea for a lot of workloads, but not all of them. Said that, you might definitely want to move there from your traditional virtual infrastructure to public clouds. You might also discover that public cloud is not the thing for you after the marketing sold you, right? So you might want also to get back from public to private. Or you might just want to redeploy what you have. So what options do we have? Here it's, so I really like this diagram. I didn't do it myself. I stole it actually from Stephen Orban, which has a blog here, okay? He's actually from Amazon. The main idea is that we are starting from here, and we want to get here. We have a bunch of options. Rehosting, replatforming, repurchasing, re-architecting, and non-options like retiring and retain, okay? Let's see how they actually, I mean, what do they mean and how do they work? Re-architect is what everybody is telling you to do all the time when you ask them, should I, how do I bring my application to a cloud like OpenStack, you know? So the typical thing that every architect is trying to tell you is that, well, you cannot take a legacy application and put it in the cloud. Applications in the cloud are meant to scale and be high available at the application layer itself, so they don't rely on the underlying host level to have high availability, for example, or scalability, no? While on the other side, if you come from Hyper-V or from VMware, you're used to something like the Hyper-V failover cluster or VMware vMotion, where basically if one host fails, your workload will simply restart on another host, okay? So those things are not part of the typical cloud paradigms. In some cases, you can have them. For example, if you have the Hyper-V driver in OpenStack, well, you can also get all the clustering and this type of failover behaviors, right? But if you move into a public cloud or if you're using KVM, you don't have it. If the host where your virtual machine is running dies, your application dies, unless you rewrite your application to make sure that it's distributed across multiple virtual machines and everything which are running, you know, inside of your cloud fabric. This is fantastic, and this is definitely the things that you should do. But there is one thing that evangelists and architects a lot of time don't think about or don't want to tell you, is the fact that if it took you 20 years to write your legacy applications, most probably you cannot do that in 1 month to just rewrite them for a public cloud, right? For a cloud. So you have to live with your existing workloads, and you have to write your new applications in the new model, that's for sure. So re-architecting, it's good typically for small use cases or for situations in which your applications was already pretty much ready for a cloud deployment. Very rare in my experience. Also, another reason for re-architecting is that you're going to have a new development and testing methodology. So instead of having old school legacy spaghetti code, you're going to go to continuous integration, continuous deployment, and things like this, okay? Those are all modern paradigms which were not necessarily available 20 years ago. On the other side, it's very expensive. It's a ton of work. Again, if it took you 20 years to do it the first time, it will cost you a ton of money and time to do it the second time. Also, there is a user's learning curve. So whenever you bring a new application to your users, it will take time to learn. So I don't know which is your experience, but mine, in a lot of different use cases, is that the end users, whenever you move a button from here to here, they need training. So think about rewriting completely the application and telling them, okay, what you used to do that way, your ERP or whatever, that used to work in a given way, now it's completely different, okay? So that's another huge cost that you have to consider. So re-architecting, beautiful, but to be taken, of course, with proper considerations. Repurchasing is of course, another obvious choice. So SaaS solutions are great when you can just fit your application into their exact identical model, okay? So stuff like Salesforce is great, okay? If you need a plain vanilla CRM with a bunch of customizations, okay? But if you have a very customized application or something very specific for your domain, and there is no vendor that made something specifically for that, that's not for you, okay? Generally speaking, if you can move to a SaaS, that's great. My experience is that not very often this can be done. Of course, big advantages. No need to write it or maintaining yourself, pay as you go. Somebody else is taking care of all of it, and you just use it, you know? You just consume it. On the other side, customization are hard to fit the requirements, data migration can be expensive, and there is a user's learning curve as usual. The easy ones. Not everything is meant to move to the next generation. You cannot imagine how many times we end up talking with customers, helping them identify which are the workloads that they really need, and discover that there's a lot of stuff that they actually don't need anymore. It can be simply retired. No cons, house cleaning is always a good thing. On the other side, there are things that are simply not meant to be migrated. So for example, if you have, I don't know, some software which is connected to some physical adapters in your infrastructure, think about a card reader for, I don't know, entry access in the building, or something to control, I don't know, the fence or, well, the tents. That thing will hardly be migrated in a public cloud, okay, or in a cloud in general, because it needs to have access to physical local resources. And now let's go to the two important ones, okay? Until now, we basically were setting the stage for the next topic. Replatforming is a thing that I really like. It's the idea of moving applications to a PaaS layer. So for example, you take, I don't know, a PHP site or an ASP.NET site or a Java website, okay? And you containerize it and you move it inside of Kubernetes, for example, or to Azure websites, okay? So basically, instead of running in your old virtual machines, where you were running Apache, IIS, Nginx, or whatever, you take them, you wrap them up in whatever the PaaS layer is using, and you deploy it directly in the PaaS, okay? That's great. You're jumping entirely one generation. Great. It takes work, meaning that you have to identify each individual application, wrap them around in a container or in a PaaS layer, and deploy them. There are companies which are specialized in doing this. And for example, Windows Server introduced containers in Windows Server 2016. And those are extremely successful because people finally can take their applications which are running on Windows Server 2003, wrap them around in a container, and run it whenever they want, okay? The same applies, of course, to Linux or whatever else. Applications becomes at least partly scalable and high available. On the con side, there is a lot of hacking involved, and not all the applications can fit this model. So what is the alternative that can fit the model for everybody? The concept of rehosting, or lift and shift. And that's actually getting us closer to where we want to get with this presentation. Examples, VMware to OpenStack, AWS to Azure, AWS to OpenStack, and everything. The idea is pretty simple. You consider your virtual machines or your physical servers as black boxes. You don't care what's running inside of those. You want to take them, move them from VMware, Hyper-V, or whatever, and put them inside of your cloud. That's actually much easier to handle at scale, because if I have to take 1,000 of those virtual machines, I don't have to know what's inside. I just take all of them, transform them, and make them run on the target, okay? Is definitely the fastest options. On the con side, you won't take full advantage of the cloud model, so scalability. Target cloud solutions might not have host-level HA, so you have to consider that as well. Why should you do this? So when you bring up these options, a lot of so-called cloud architects will just look at you like, why do you do that? Rewrite. The reality is that can be done easily. You take them, you move them, they run, they work, okay? Typically, you spare a lot of money. For example, if you move from VMware to OpenStack, you are sparing all the VMware taxes, meaning that you're reducing a lot of your TCO, your total cost of ownership. In short, you're sparing money, and you can use that money to, for example, rewrite the next generation of your application. Plus, you're having all your applications running on the same type of infrastructure. Much easier to manage. You don't have two different layers of two different type of infrastructure. So in short, this is usually a great idea. Why doesn't everybody do that? Because it's difficult. If you do it manually, there are a lot of steps involved. You have to consider that you have different drivers. If you run a virtual machine on Hyper-V or KVM or ESXi, it's true that they are all virtual machines, that they're running on completely different type of virtual hardware. Okay. For example, on KVM, they're running on Virtual.io. In ESXi, you have VMware tools. On Hyper-V, you have LIS, and so on. Then you have to rebuild in Etherd images, because they will have different drivers. You will have to consider that SC Linux will never let you boot, because it considers that you have a different hardware under you. So you have to tell SC Linux that you have a change in configuration. All your PCI IDs will change, okay? Meaning that you have to tell your network configuration to retain the proper names and everything. Provisioning agents like Cloud Init or Cloudbase Init or the Azure WO Linux agent and so on need to be injected, because you don't have them on VMware, you have them on OpenStack, no? If you Google how do I migrate a VM from VMware to OpenStack, for example, you have plenty of guides which are telling you do this, do that, do that, do that, do that, okay? The problem with that is that it's heavily manual, error-prone, and definitely doesn't scale if you have to do 1,000 of those things, no? So in order to solve this type of problem, we wrote a project called Coriolis. Fully automated lift and shift migrations from end-to-end cloud or virtualization solutions, scalable, should be able to do one migration or 1,000 at a time, needs to have a REST API, and needs to use Keystone for identity management. So basically, it has to look and feel like an OpenStack project from every possible perspective, okay? Our goal at some point will be to provide it, let's say, as part of the generic OpenStack projects like Nova, Cinder, and everything. So that's why we wrote it exactly like those. You have a REST API endpoint, a conductor which is in charge of, let's say, orchestrating all the operations, and you have a bunch of workers. The workers are the one in charge of connecting to your source and target infrastructure, okay? Barbican is another OpenStack project that we're using for storing secrets. Why do you need secrets? Because you will need to connect to a source cloud and a target cloud, let's say VMware, OpenStack, and you will have to put credentials to connect to either one or the other. You don't want those credentials to float in clear text across the entire service, okay? So all of these things are microservices written in Python, communicating among each other via MQP, RabbitMQ basically, using a MySQL or whatever other database for keeping the configuration, and running wherever you prefer. So the easiest thing is that you package them all together, for example, in a single virtual machine, Linux or Windows, and you can deploy that virtual machine wherever you want, or you can distribute all those things wherever you prefer. For small deployments, take a machine, put everything in there, deploy it, off you go. If you need to have a very large migration, like tens of thousands of virtual machines, well, you might want to split them around and have dozens of workers, okay? Because this thing, again, is meant to scale as much as you want. The workers will talk among each other, of course, in order to create a path so that the data will flow from one side to the other. It's using, as we're saying, Oslo components, like Oslo service, Oslo config, and everything. Keystone, Barbican, Swift. So those are OpenStack components that we are just reusing. Coriolis can also be integrated directly in your existing OpenStack cloud. It becomes just another service like Nova, Cinder, Neutron, and everything. Or it can be inside of its own completely separated deployment. The typical trial images that we give around, for example, are just Ubuntu machines with one Keystone, one Barbican, Swift, and Coriolis, okay? Easy, simple. Supported clouds and virtualization and solutions, OpenStack with KVM, Hyper-V, ASIC, Azure, AWS, VMware vSphere, Hyper-V and System Center, Sense Server, OVIRT KVM, Oracle VM, and GCE also to be added soon, okay? Coriolis itself, it's completely agnostic, so the core of the project doesn't know anything about your specific clouds, okay? So there is no assumption made inside here about how VMware or OpenStack or whatever else works. The components which are in charge of talking to OpenStack or VMware and everything are called providers, and they're like plugins, and they live inside of the worker. So the worker has a configuration file, written like any other OpenStack configuration file, think about NovaConf and everything, where you're just saying which are the workers which are available. The scheduler will simply know which workers are able to do which type of migration, okay? What do those workers do, those providers? For example, they connect to VMware and they get information about a set of virtual machines that you want to migrate. So they know how big is that machine, what networks is connected to, how many disks it has, what type of storage, you know, how big is the storage, how many virtual CPUs, how much memory, and so on. Then workers will connect to the OpenStack target cloud and create, for example, volumes for each of the disks which are going to be migrated. Then there is some magic in extracting all the data from VMware, putting it either on a temporary storage like Swift, or moving it directly to the target cloud. We will talk about this later, okay? The idea is that the workers don't rely on internal features in OpenStack, in VMware and everything. They just interact with the public cloud. So you don't have to install anything inside of OpenStack or inside of VMware or whatever else, okay? They're using, so when the APIs are not enough to perform a given activity, they're using temporary VMs, which are simply spawned on the target cloud or the source cloud to perform some work. For example, when we copy OV data, instead of copying it directly, let's say, in Cinder, from Cinder create a glance image, and from glance creating a volume, for example, or a root disk for an instance, we create the volumes, we spin up a temporary VM, we attach the volumes to that VM, and then we stream all the data to an SSH tunnel to that temporary VM, which is simply DDing it into the volumes at a given offset, you know? So for example, if we're migrating a disk, which is 1 terabyte in size, but the content is only, for example, 100 gigabyte, you know, distributed across the disk, what we do is to take only the data which has actually been written, compress it, encrypt it to the SSH channel, send it over, and write it, okay? So at the end of the day, you will have a one-to-one image of the same disks, okay? All the operations are task-based, meaning that the migration itself is not a one-off thing. It's divided in a lot of different bits and pieces. For example, connecting to the source target, creating the volumes, copying the data, blah, 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 okay? All those tasks can be parallel or sequential. So Coriolis knows whenever it needs to wait for a task in order to execute another one, okay, so sequential, or whenever tasks can be executed in parallel. For example, if I have to create multiple volumes, I can do that in parallel, okay? Here are some examples that you can get later on, okay, but I will do some demos. The stage, so if you're moving, for example, from the same technology to the same technology, for example, you're moving from an OpenStack Icehouse on KVM to another OpenStack, let's say Okata, still on KVM, you have the advantage that you're not changing the type of hypervisor. So we don't have to modify basically the content of the virtual machine in order to make it run on the target, because it's the same hypervisor on one side, the same on the other. Companies use Coriolis a lot for this when they migrate from an old version of OpenStack to a new one, because it will be simply impossible to do it in place. No? If you migrate Newton to Okata, it's easy. If you do Icehouse to Okata, forget about it. There is not a clear migration path unless you then do Icehouse Juno, Juno Liberty, Liberty Mitaka, and so on, okay? So that's absolutely impossible. So for all the other cases, like for example, VMware to OpenStack, you need to do all those steps to tell your machine that it's not running anymore on VMware, but it's running on KVM or Hyper-V or whatever else. How does that work? We call this process OS morphing. So what's happening basically is that we spin up a temporary VM. That VM gets attached to the volumes. The volumes are inspected. We discover what type, so all the volumes are mounted. We discover a type of operating system is available. Based on the type of operating system, we run another plugin-based architecture, so which contains plugins for each specific operating system. Think about Ubuntu, Debian, Windows, RHEL, and so on, okay? And that will perform all the actions which are specific to that target platform, okay, in hypervisor. Example, rebuilding initrds on a Red Hat image or a CentOS image, because otherwise it will never boot. Supported operating systems, so these are the type of guests that we support today. So Debian, Ubuntu, SUSE, Red Hat, CentOS, Oracle Linux, this is basically the same OS, no? With some differences, Fedora, OpenSUSE, and Windows 7, 8, 8.1, and 10, and all the Windows Server family. Okay, those are all the supported ones. To some extent, we support also XP in 2003, even if Microsoft doesn't support it anymore, but sometimes customers ask us, okay? So we do that on demand, but we have no intention of maintaining it as part of the upstream, or open source branches. So Coriolis has a REST API. Here is the Postman examples. Coriolis has a command line interface that I will show you how it works. Even the command line interface works like an OpenStack command line interface. It's actually written using Cliff, which is the same library which also, for example, the OpenStack CLI uses, okay, CLI. I will skip this part because I will show it. And then we have a graphical user interface, a GUI, which is JavaScript. And since we have a REST API, the REST API is called either by the command line tools or by the graphical user interface, okay? So all the logic is behind. So what you can have in the CLI and in the GUI is the same thing. It's just that the GUI is much more user-friendly. We typically prefer the command line because DevOps prefer the command line, okay? So people use Horizon in OpenStack when they have to do a little bit of operations, but when they have to automate a lot of things, they typically go and do, Nova boot, Cinder create, and so on. What about downtime? Coriolis introduced a disaster recovery as a service feature called Replica. If the source cloud allows you, data is backed up incrementally to the target while the source VM is running. And that's actually very important, and I will demo it to you right now. How does it work? So it uses, for example, technologies like Cinder Backup or VMware change block tracking or Windows VSS, okay, to perform a snapshot and allow you to leave the machine running on the source, take a snapshot, extract the data incrementally, so that the first time you do, for example, a full backup, but the second time you do it only with incremental bits and pieces, and then you restore basically the machine on the target cloud, okay? It can be also app consistent, meaning that, for example, VMware allows you to perform caching in a snapshot, which means that the VMware tools will talk to the components in the operating system and the guest operating system. And if the applications, like, for example, databases, think about SQL Server, Oracle, allow it, they will basically stop writing data on disk. For a database, it means typically writing data in the logs, okay, but not on the data file. So when you restore the image that you copied over, it will be completely consistent from the application perspective. So you don't risk to get a moment in which you wrote a file halfway. On Linux, it uses file system freeze. It basically blocks the writes to the file system until the snapshot is taken, which is really fast, and then it keeps on writing. No? And what you are backing up at the moment is the snapshot. I think I can go to the demo. The timer here is correct, right? I have 12 minutes.
More or less, yes.
OK, thank you. Any questions so far? Yes?
For example, if you have a VMware deployment, and
Yes.
let's say you want to migrate all your workloads to, let's say, OpenStack or Newton,
Yes?
and then you migrate back, how much of the configuration options and all the stuff are lost in translation?
That's a great question. So the idea behind Coriolis is to migrate any type of workloads and any type of configuration, okay? So that's why we call it migration as a service, because it's software defined from every perspective. The idea is that we read everything that we can from the source, and we recreate it on the target. So a real infrastructure as a service allows you to get all the type of information. For example, if I ask OpenStack Neutron to get me all the details about my network, I get them. I get the name of the networks, the subnets I'm using, the type of segmentation if I want, the IP addresses to use and everything. No? If I do that on VMware I don't have that option. I just know the type of network, right? If I do it on AWS, on Azure, I have it, okay? If I do it on Hyper-V, I also don't have it. The only thing I know is the name of the switch to which I connect, okay? Other things, we save, for example, the MAC addresses. When we migrate VMware to OpenStack, we recreate the machines, and we apply the same identical MAC address from the source. So all those things are retained as much as possible. I will show you more now during the demo. For example, network is live. Yes. So let's say that we do, well, let's start. Let's start by enumerating the endpoints that we have on this OpenStack deployment. So this is just your regular plain vanilla OpenStack deployment. Okay? You're familiar with this command and with the idea of endpoints?
Please use the mic.
So this is just regular OpenStack. So if you look around here, I will find familiar things like image, which is glance, identity, which is keystone, and so on. You see that there are some new services called service type migration in Coriolis, okay? So keystone, simply, so whenever we want to know where our endpoints for doing the migration are, we are simply asking keystone where they are. So all I need is a token. Now, next thing, if I do Coriolis endpoint list, I'm getting the list of endpoints. Increase a bit the font. an endpoint is a source or a target, a cloud to which I want to connect. No? In our demo, source VMware, target OpenStack. No? We have 3 there from various demos that I'm running, so OpenStack, VMware, in Oracle VM, okay? But you can have also AWS, Azure. So for any time, you have a type, a description, and you could say description, I don't know, my development environment, my production environment, whatever, okay? What does this contain? So if I do endpoint show, you see that it looks and feels like an OpenStack client, okay? The same type of syntax. It tells me all the detail, and then I have the connection info, which are in a secret ref. So I cannot see them directly here. And that's very well intentional, because they're stored in Barbican. So I do Barbican secret get payload. Thank you. And I can see that I have all my data over there. Now you see that I have it's just some JSON with all the data that normally you will pass when you connect to OpenStack. No? The same thing will applies to VMware. So I will have my endpoint APIs, my username, my password, and everything. What can I do with this? Now I need a Coriolis replica list, so I'm listing all the replicas that I have defined. What do I have in a replica, and how do I create a replica? I already created them because, of course, the demo has to run fast. If I take this one, it tells me that I have one instance called Ubuntu 14.04. I'm going from this endpoint to this endpoint over here. So I'm putting the IDs. So if I do Coriolis endpoint show, I will see them, okay? And then some configuration. For example, I want to map what is called VM network local on VMware. I want to map it on a network called public on OpenStack, and another one called get network to another network called private. Plus, I want to use a flavor called Coriolis demo, okay? Plus, I can have also other options, okay, which are not getting into details right now. But basically, this is a mapping between the source environment and the target, especially for situations in which I cannot just read it automatically. If I go into VMware, which is here, this is my Ubuntu machine, which is running. And I do something like hello OpenStack. See, Coriolis sticks here. Okay, so I have a file called Coriolis sticks with that stuff. So you can see here nothing different in my plain vanilla VMware environment. What am I doing right now? I take the ID here. And I do a Coriolis replica, execute with ID. Voila. It starts, and I can see that I have a lot of different steps involved. For example, get instance info, deploy replica disks, deploy source resources, deploy replica target resources, and so on. Okay? I can anytime go and take a look at how it looks like. I just have to do a Coriolis replica execution show, passing the ID of the replica and the ID of the execution. And here I can see all the steps which are going on. So this is basically keeping me updated on what's going on. Huh? For example, it went on the target resources. So it went to the source, fetched information about the machine, went on the target, found out that we already deployed volumes for those disks, so we don't need them. We use the old ones. And then we started creating some temporary resources. A keeper, a neutron port, a floating IP, a security group, and then we are connecting to a temporary VM, which is running on OpenStack. This is just a worker VM, so if I'm now refreshing, you will see that it went to this next step, which is replicating disk, which means reading the data out of a change log trapping backup from VMware, streaming them on the target, writing. How big is the disk? The disk is 5 GB in size. How many changes do we have? 1 MB and something. Since the last time that I did a full replica. Of course, I did the initial time that you do it, it will have to copy the entire disk. But since I have only a few minutes for a demo, I previously did the entire operation. The second time it will discover it already did it, and so it will be really quick. Actually, it already finished. Then it will just clean up, delete source resources, delete target, and everything. Okay. So if I look at my OpenStack environment, which is here, and I look at my volumes, I will find a bunch of volumes, including Ubuntu 14.04 images, which are here. Okay? So those contain a copy, byte per byte, of the source disks from here. So those are not the virtual machine, those are a replica. If I execute a replica again, it will again look for changes and copying them over byte by byte. Okay? I can let this thing running forever, keeping on looping. And basically, if the VMware environment catches fire, I don't care because all my machine data is here. So I don't need VMware anymore. I can anytime start my machine here. Huh? What am I doing next? For instances, let's see what we have. I don't have any instance, okay, at the moment. What am I going to do right now is to take my replica and actually perform the migration. So Coriolis migration deploy replica. It started, and again there are a bunch of tasks. I can just go and look at Coriolis migration show. And again, I will have a new temporary VM which comes up. I can actually go and see it. It's a temporary name coming up with all the data. This is just an Ubuntu machine, or Windows for Windows VMs, okay? Which comes up and it's just temporary and has the job to perform stuff that otherwise I wouldn't be able to do from outside. Waiting for connectivity. And in a few seconds it will keep on running. Okay? I normally put a watch for this, but it will take the entire screen, so it's also what I typically do is something like this. So I'm just scraping on the status and I'm waiting for it to run. You see, at this point, which are my tasks which are completed, and which one are running, and which one are pending, okay? So for example, these ones need to wait for this guy to finish before being able to perform the other operations. I can go and look at my machine here. I see it's running.
We'll continue with our last presentation, and I'd like to
Our console, you see it's running well.
8 hours.
And I can also see that it's using Cloud Init to perform all the initialization and allows us to log in with a temporary keeper. Okay. The next step completed, we move to the other one. Let me show you. So it went through the steps, and at the end is attaching all the volumes, in this case only one, to the instance. Next thing, which is doing, is connecting there and trying to discover what type of operating system you're running there. It's mounting again all the partitions, so it will take another few seconds, and then it will just tell you, voila, I discovered an Ubuntu 14.04. How do I discover it? By just analyzing, all the configuration files. At this point, I know it's Ubuntu, I know it's 14.04, so I run a specific plugin which knows how to deal with Ubuntu 14.04. Right? If it were Red Hat, I would run something completely different. What do I have to do? I have to remove the OpenVM tools because I don't run on VMware anymore. And I have to inject Cloud Init because I'm going to OpenStack. Dismounting of OS partitions. It's almost done. Removing temporary stuff. And spawning the final VM. Creating migrated instance. We can go here. It's coming up. Also. Here it should be pretty much finished. There you can see removing replica disk snapshots because we took a volume snapshot in order not to disturb actually the replica if the replica is continuous. And that's just the final cleanup on the disk. Okay? We can leave it running. You see Cloud Init running over there. So actually injecting Cloud Init work. Voilà. Okay. And voila. Hello, OpenStack Days. Thank you. Okay, that ends up the demo. We are also slightly over time. There is also a graphical user interface, which I'm not going to show you because I don't think it's particularly necessary, but it performs the same thing that you saw on the command line. Okay. Thank you, guys. I don't think we have time for questions. Yes. So we move outside.
Yeah, thank you very much. Actually, after visiting OpenStack summits and conferences for the last 5 years, I'm quite surprised that this thing worked. I mean, this is really difficult stuff what you've been showing us, and it was just beautiful.
I just had a guy behind typing on it.
Oh, okay. Then I understand.